Hi there, welcome back. This is WebLearn. We want to look at this section of probability, the fundamental counting principle. The first thing I want us to look at is this one. We call it n factorial. When you see an exclamation mark in front of an n, we call it n factorial. You also find this on your calculator. Here it is. Here it is. How do we use it? I want us to consider a scenario. We have got 4 students: student W, student X, student Y, and student Z. We want to sit these 4 students on these 4 chairs. We want to sit these 4 students on these 4 chairs. Now, how many different arrangements or permutations can we come up with? Let's examine that. For the first chair, we have got a choice of 4 students. That is, we have got 4 students to choose from. So for the first chair, it can be this student W, or student X, or student Y, or student Z. And then when we go to the second chair, we are left with only 3 students to choose from, because the 4th student is already sitting on the first chair. So that gives us a total of only 3 choices. And then when we go to the third chair, 2 students are seated already. So we are left with only 2 students. So that gives us 2 choices. So it can be the other student or the second one. And then when we go to the last chair, finally, we are left with only 1 student who is not yet seated. So there is only 1 possibility, or there is only 1 choice. So that's a 1. And just like on probability on a tree, we multiply to get the total number of possible arrangements. This is going to give us 4 times 3 is 12, times 2, 24, times 1, that's 24 different, that's 24 different arrangements, or 24 different permutations. So this will be 4 factorial. 4 factorial is 4 times 3 times 2 times 1, and it gives us 24. It gives us 24. That's how we use the factorial function. So you can do this on your calculator. It's 4. You press a shift, you press this button. That's 4 factorial. That gives you 24. And then let's consider something else. All right. This time we have only 3 chairs. This time we have 3 chairs only. And we want to find different combinations. How many different combinations can we come up with? Or different, not combinations. How many different arrangements or permutations can we come up with? We have our 4 students, 1, 2, 3, 4. For the first chair, we've got a total of 4 choices. So this will be a 4. And for the second one, 1 student is seated already. So we are left with 3. So it's 3 choices. And for the third chair, we are left with 2 students. So it's 2 possibilities. So this is going to be equal to 4 times 3, 12 times 2. That's also 24 different combinations. That's 24 different combinations. All right, there is a different way of doing this, or let me say there is a formula that we use to deal with cases of this nature. We have another scenario here. We want to choose a 5-digit password here for my phone, and the numbers that are available for us to choose from is from 0 to 9. That is a total of 10 digits. 1 2 3 4 5 6 7 8 9 10, and no repetition. That is, repetition is not allowed. The first digit, how many possible choices do you have? Choices of numbers. We have 10 numbers to choose from, so there is a total of 10 choices. And then when we have chosen the first digit, we are left with 9 digits to choose from. So we've got a possibility of 9 choices for the second digit. So this is a 9. We have chosen 2 digits, and in our pool we are left with only 8. So for the third digit we've got 8 choices. That's an 8. And then we've chosen 3, we're left with 7. So for the fourth one, we've got a total of 7 choices. And we've chosen 4 digits, and we are left with 6. So we have got a choice of 6 digits to choose from. 6 possibilities. That is a 6. Now, to get this is going to be equal to 30,240 different passwords to choose from. Now, to deal with this one without having to write them down like this, there is a general formula that we can use, which says n factorial divided by n minus r factorial, where our n is the number of items that are available to choose from, and r is the number of items to be chosen. So in this case, we have got a total of 10 items that we can choose from, or 10 digits. So to get the total number of passwords that we can come up with, 5-digit passwords, we are going to say 10 factorial, because we've got 10 digits to choose from, divide by 10 minus, it's 1 2 3 4 5. We are only going to choose 5 digits, so it's minus 5 factorial, and this is going to be 10 factorial divide by bracket 10 minus 5 close bracket and factorial. This is going to be the same, 30,240. Remember, we said these arrangements, we can also refer to them as permutations. There is another function also that we use on the calculator. Here is the function. This is the function. It's NPR. NPR. Sometimes we write it with an N, P, and then an R. Sometimes we write it as P bracket N R. It's simply telling us that the permutation here, we want to choose 5 digits from a total of 10. So when you do it, it's going to be 10p5, and then you go to your calculator, it's 10 shift, you press this function, and then 5. It gives you 30,240 different combinations. Okay, with this one we have the numbers 1 to 7, and our task this time around is to determine how many 4-digit numbers that we can get from these given numbers without repetition. How many 4-digit numbers can we get here without repetition? The first of those 4-digit numbers, our first scenario, the 4-digit numbers should be even. 1, 2, 3, 4. The 4-digit numbers should be even. So let's first satisfy that condition. For a number to be an even number, it has to end with a 2 or a 4 or a 6. So in general, we are saying all even numbers end with an even number. They also end with a 0. But within the set of numbers that we have been given to choose from, the only even numbers we have is 2, 4, and 6. So we are saying we have a total of 3 choices here. For our number to be an even number, it has to end with a 2, a 4, or a 6. And then we have chosen one number. We are left with how many to choose from? We are left with 6. So here we've got 6 choices. And when we have 6 choices, it means we have 5 choices here, and we have 4 choices. And then we multiply. What do we get here? We get a total of 364 digit numbers which are even. And then the second scenario, the 4-digit number has to be greater than 6,000. It's a 4-digit number. For it to be greater than 6,000, it has to start with either a 6 or a 7. That is 2 choices there. If it starts with either a 6 or a 7, it means it's going to be 6,000 and something or 7,000 and something. Those are the 2 choices, either 6,000 and something or 7,000 and something. That is the 4-digit number. And then we have chosen one. We've chosen 1 digit. We are left with how many choices? That is, we are left with 6 choices. And then after choosing these 2, we are left with 5. That is 5 choices. After choosing 3, we are left with only 4 choices out of 7. Then we multiply them. What do we get? We get 240. So we can get 240 4-digit numbers which are greater than 6,000. And then the last scenario, this one has a combination of 2 conditions. The first condition, it has to be an even number. The second condition, it has to be a number greater than 6,000. So 1, 2, 3, 4. We need to satisfy these 2 conditions, starting with the first one. For a number to be greater than 6,000, it has to start with either a 7 or a 6. We have to consider these two scenarios, but we are going to consider them separately. The reason why we are going to consider these two separately, those which start with a 7 and those which start with a 6, is because the second condition is saying the number has to be an even number. So when it is starting with a 6, which happens to be an even number, is going to affect also the way we choose the second digit here. So if it is starting with a 7, it means there is only one choice, which is a 7. Starts with a 7, that's one choice. And then after choosing one number, we are left with how many numbers? Okay, sorry, the second condition, if it's starting with a 7, is one choice, and then it has to be an even number. And remember, for it to be an even number, it has to either start with a 2, a 4, or a 6 from our set of numbers. 2 is an even number, 4 an even number, 6 an even number. So we've got a choice of 3 numbers here. We've chosen the first one for it to be a number greater than 6,000, that is starting with a 7,000, with a 7, that is 7,000 and something, and then it ends with a 2, a 4, or a 6 for it to be an even number. Now we have chosen 2 numbers out of 7. We are left with 5 choices. So from 5 choices here, we have chosen this one. We are left with 4 choices, and then we multiply. This is going to give us 60. We have a total of 60 4-digit numbers here which start with a 7, and then those which start with a 6. If it is starting with a 6, it's one choice there, and then it ends with an even number. Our even numbers is 2, a 3, and a 2, a 4, and a 6. But we have already chosen a 6, so we are left with only 2 even numbers. So we have a choice of only 2 even numbers that we can choose from for the last digits. So we have chosen 2 digits. We are left with we're left with choosing the middle 2, and we are choosing from a total of how many choices? It's a total of 5 choices, because 2 it's a total of 5 choices because 2 of the digits have been chosen already. So this is going to be a 5, and this is a 4. We multiply. After multiplying, this should give us a 40. Now, to get the total number of 4-digit numbers that we can get under these conditions, we add these two. So it's 60 plus 40, which is equal to 100. So we can get a total of 100 4-digit numbers which are even and which are greater than 6,000. Remember, practice makes perfect. So try to do as many examples as possible. Enjoy.